I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing energy bar charts. Alright, so we're going to draw energy bar charts to represent the law of conservation of energy. So the law of conservation of energy tells us that if the energy is not going to be created nor destroyed. So when we're drawing it for a system, so a situation we're going to have is a marker is dropped to the floor. So this is what a blank energy bar chart looks like. So the blank energy bar chart shows that we have an initial situation. We have an energy flow diagram. So the flow diagram includes the system, and anything that is not in the system is the surroundings. And then we have a final situation. So what we're going to do is we're going to define the initial situation as the marker. If it's being dropped, that means it's in the air to begin with. And the final situation will be defined as the marker is hitting the floor. So the first thing we need to do is define our system based on what can have mechanical energy. So the mechanical energies would be your kinetic energy and your two potential energies, the stored spring potential energy and the gravitational potential energy. So the marker is moving at some point, so that has kinetic energy. So we're going to put that in the system, and then we're going to put the Earth because there's no spring. We're not going to put anything else. Those two objects are what we have. So now we're going to ask ourselves three questions for each the initial and final situation. In the initial situation, is there anything moving? The answer is no. The marker hasn't been dropped yet, so it's not moving. Is there any spring stretched or compressed? Well, we don't have a spring in the system, so no, there's no spring that's stretched or compressed. And lastly, is there anything that has a height greater than zero? And the answer is yes. The marker is above what we defined as zero as the floor. So we're going to have gravitational potential energy. Now, the energy flow diagram is important. Next, we're going to show how the energy flows. So the energy goes from the Earth to the marker. So it's taking that gravitational potential energy and changing it to kinetic energy. So the final situation, again, you're going to ask yourself those same three questions. Is there anything moving? Yes, the marker. Is there a spring stretched or compressed? No, because there's no spring in our system. Is there anything that has a height greater than zero? The answer is no, because the marker has reached the floor at that point, so its height is zero. Now, the point of drawing the energy bar charts is to end up writing our conservation equation. So a law of conservation of energy equation, which states that the initial situation plus any energy that's transferred in or taken out of the system is equal to our final situation. So the initial situation is UG plus W, which is the anything that is working on the system by transferring energy in or out, is equal to kinetic energy. Now, in this case, work is going to be zero, but I have my students always write plus W so that way we don't forget it when the value is non-zero. So that we know that in this case, UG is going to be equal to K. Alright, so here we have a second situation where we have a car that is compressed against a spring and it is launched up a hill and is moving at the top of the hill. So we're going to start with our blank energy bar chart, and we're going to start by defining the system. So again, you define the system with anything that can have mechanical energy. Again, mechanical energies are the two potentials, stored spring energy and gravitational potential energy, and kinetic energy. So those are the three types of energy, two potential and kinetic. So what we know is that the car is going to be moving, so that's going to be kinetic, so that can go in the system. We have the Earth because the hill is going to be the car is going up the hill, which is giving it gravitational energy, and we also have a spring, so we're going to put all three of those things in our system. So where's the energy to begin with? Well, let's ask the three questions. Is there anything that has a height greater than zero? No, because the car hasn't moved up the hill yet. Is there any spring stretched or compressed? The answer is yes. And lastly, is there anything that is moving? And the answer is no, the car hasn't been pushed by the spring yet. So the beginning situation, we have all stored spring energy. Now, the energy flow is going to go from the spring to the car, and the car transfers some of its energy to the Earth. and that's just accounting for gravitational energy. So again, we're going to ask ourselves the same three questions in the final situation. Is there anything that has a height greater than 0? In this situation, yes, the car. Its height's greater than 0, so it has gravitational energy, and that's shown by the arrow going from the car to the Earth. Is there anything that is moving? Well, yes, the car's still moving. It tells us that in the problem, that it's still moving at the top. Is the spring still stretched or compressed? The answer is no. The spring's no longer stretched or compressed. So I have two types of energy that I need to represent. So I can see that I'm going to represent kinetic energy and stored spring energy. Now you have to remember that this is just a qualitative representation of the conservation of energy. So what matters is that in the initial situation, I have stored spring energy, and I drew a total height of 4 bars. In the final situation, I have two types of energy, kinetic and stored spring energy, and the total height of those two has to be 4. So I could have drawn kinetic energy to be 2 and gravitational energy to be 2, as long as they were add up to a total of 4 in the final situation. Now remember, the important part of drawing the bar charts is to get our conservation equation. So our conservation equation tells us that the initial amount of energy plus any energy transferred in or out, which is the working, is equal to the energies added together in the final situation. So in this case, we have the stored spring energy is equal to the kinetic plus gravitational. And remember, we write plus W so that we don't forget it when it's non-zero. In this case, it is 0. So UG plus W is equal to K plus UG. So this is a brief introduction on how to draw energy bar charts for situations with objects not working on systems. I hope you have a great day and an even better tomorrow. If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.